Hello everyone, welcome back to Engineering Today. And at last we have some good news to discuss regarding SpaceX. We'll also discuss some news regarding Boeing and some updates from the UK regarding their self-eating rocket. SpaceX's 13th Starlink satellite launch finally took place on Tuesday, October 6th, when the company's Falcon 9 rocket blasted off from the ground, carrying the next batch of 60 Starlink satellites. Tuesday's launch was an alternative attempt for SpaceX's Falcon 9, as its previous two attempts were aborted due to bad weather. SpaceX's two-stage reusable Falcon 9 rocket lifted off straight up high from Pad 39A of NASA's Kennedy Space Center at about 7:29 a.m. Eastern Daylight Time. The rocket took a good start after the clock reached T-0, with its core booster blasting fire from its mouth like a beast, carrying a full stack of 60 Starlink satellites to the orbit. As per that, SpaceX CEO Elon Musk wrote on Twitter, 5 minutes from the launch, looks good so far. At T-60 seconds, Falcon 9's autonomous internal control took over the rocket and performed an initial startup. SpaceX's broadcast team, as usual, was presenting the whole launch in a live stream. Approximately 9 minutes after the liftoff, Falcon 9's first stage booster returned to Earth with a successful landing on one of SpaceX's drone ships in the Atlantic Ocean. Elon Musk also tweeted shortly after the deployment of Starlink satellite that once these satellites reach their target position, we'll be able to roll out a fairly wide public beta in northern US and hopefully southern Canada. Other countries will follow as soon as we receive regulatory approval. As per a letter that the company wrote in the FCC filing, in order to expand its assessment of the end-to-end capabilities of its satellite system, SpaceX seeks authority to test these user terminals on seagoing platforms for a period of up to 2 years. Specifically, SpaceX proposes to deploy a total of 10 Earth stations across up to 10 vessels, including 2 autonomous spaceport drone ships used to land rocket boosters at sea. With another successful launch and landing of the Falcon 9 rocket, SpaceX is now up for the GPS-3 communications satellite launch for the U.S. Space Force. This launch is set for the near future. Let's now check how SpaceX CEO has reacted to the consecutive launch abort SpaceX has suffered. Elon Musk decided to visit the company's Launchpad and check the site by himself after the launch aborts for 2 Falcon 9 rockets last week. The previous week was very disappointing for SpaceX as the company canceled 2 of its crucial launches. On Thursday, October 1st, SpaceX aborted the Falcon 9 launch, which was carrying the next batch of 60 Starlink high-speed internet satellites. The launch was aborted by an unexpected ground sensor system reading, although later on October 6th, Falcon 9 successfully lifted off with the satellites. The next day, on October 2nd, a Falcon 9 rocket, which was carrying a GPS-3 communication satellite under the U.S. Air Force, was aborted just a few seconds before its liftoff. As per Musk's Twitter post, he stated a reason: that an unexpected pressure rise in the turbo machinery gas generator. But for those back-to-back launch aborts, the CEO decided to check the site by himself. We'll need to make a lot of improvements to have a chance of completing 48 launches next year, Musk tweeted shortly after Falcon 9's launch was called off. This week, Elon Musk announced that he would come to Florida to visit SpaceX's launch site to check the situation. We're doing a broad review of launch site, propulsion, structures, avionics, range, and regulatory constraints this weekend, the CEO wrote on Twitter, referring to SpaceX's Cape Canaveral site. I will also be at the Cape next week to review hardware in person. For the past few months, Musk has been busy focusing on its Starship prototypes, which has been currently building at SpaceX's Boca Chica facility in Texas. But now's the high time for the CEO to visit SpaceX's Falcon 9 launch sites, thus visiting both SpaceX's Cape Canaveral and Kennedy Space Center launch sites will be going back to more established designs. Let's take a quick look regarding a news relating to Boeing. The private aerospace company, Boeing, is building a satellite payload prototype to develop a secure communications architecture for the U.S. Space Force's Evolved Strategic SATCOM (ESS) program. On Thursday, October 1st, the company announced that they'd received an amount of $298 million from U.S. Space Force to work on this project. With this project, the U.S. Space Force is planning to replace their current Advanced Extremely High Frequency AEHF satellites, which were developed by Lockheed Martin, with the new SATCOM ESS. The three competing companies, which include Boeing, Northrop Grumman, and Lockheed Martin, who previously built AEHF satellites for the U.S. Space Force, are now developing dissimilar designs for the ESS program. Each of those three companies are developing satellite prototypes, which is targeted to be complete by 2025. Like AEHF, Space Force's new ESS program will also provide secure, jam-resistant communications, but with some modifying features for high-priority military operations and national command authorities. Boeing has a lot of experience in case of communication satellites as a longtime supplier for military communication satellites. The company previously worked for the Wideband Global Satcom WGS constellation, and also has a record for working on the Protected Tactical Enterprise Service and Protected Tactical Satcom programs. These programs are for developing survivable, secure, and resilient tactical-level communications for the U.S. military. Now it's time for some interesting news from the UK. A rocket that is capable of feeding itself sounds like a fictional story, but now it's becoming a reality. The UK government plans to extend the development of self-eating rocket techs that could gobble themselves up on the way to orbit. UK's Ministry of Defence's Defence and Security Accelerator, DASA, has spent around £90,000 or $117,000 US for the current exchange rates to continue the development of the autophage rocket engine. Researchers of the University of Glasgow in Scotland were working on this autophage engine under the DASA funding. According to Patrick Harkness from the University of Glasgow's James Watt School of Engineering, this unique tech is well fitted, especially for small rockets, because scaling down a rocket reduces the mass of the propellant more than it reduces the mass of all other components, including the tanks that hold the propellant itself. As per Harkness, the autophage concept is simple. Burn the tanks as well, he added. That saves the excess mass, and it means that we can miniaturize the vehicle without hitting this wall. The research team of Glasgow University has already conducted a performance test for the engine, in which they test-fired a version of the autophage engine that's burned all solid propellant. As per that, team members said they would use the DASA funding money in the research to use a more energy-rich hybrid propellant for other tests. The body of a hybrid autophage rocket will be a tube of solid fuel containing a liquid oxidizer, Harkness of James Watt described. The entire assembly will be consumed, from the bottom up, by an engine which will vaporize the fuel tube, add the oxidizer, and burn the mixture to create thrust. The engine will have consumed the entire body of the rocket by the time the assembly reaches orbit, and only the payload will be left. It's a much more mass-efficient process. If all goes according to plan, researchers are targeting next year to test-fire the hybrid engine at Kingston University in London. After completing all the tests, this new autophage engine tech could be a charm for industry. This engine could provide the UK with a better place for the launch of small satellites in this industry. Small satellite market is also a growing industry, and many nations are preparing their rockets to secure a better place in it for over a long term. As per today, two of the biggest aerospace companies in this field are American companies Rocket Lab, which offers dedicated rides to orbit with the help of its Electron booster, and the other one is billionaire entrepreneur Elon Musk's company, SpaceX, which is continuously increasing small payloads as ride shares on its workhorse Falcon 9 rocket. The UK has a strategic aim to secure 10% of the worldwide space industry by 2030, and we believe that our autophage industry is uniquely well placed to help deliver on that ambition, Harkness said. We're looking forward to continuing our work to develop the engine and help the UK find its place in space. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.